This is Lab 4, and in this we're going to talk about surveying, or how do we measure distance to other planets. So we're going to look at one method, parallax, in order to see how far away something is. So we're going to use triangulation, which is also used by surveyors to map things like parking lots, bridges, whatever. The theory is there's a relationship between the sides and angles of right triangles. So what I'm going to have you do is practice this on a table, and then I'm going to have you go outside and find some distant object, like a tree or a flagpole or some other thing. And we're going to use a right triangle to measure how far it is without actually having to measure the distance. So we're going to start off with a table. So I want you to go find a table in your house. It could be your dining room table or anything, as long as it's a rectangular table. And the first thing I want you to do is measure the short side of the table. So I did that on my table, and it was 76 centimeters long. Now what I want you to do is lay a string across the diagonal of the table, and I want you to measure, using a protractor, the angle that the string makes with this. So this angle A. So for me, I measured that angle, and I got 67 degrees. So now I can look up either on a calculator, or the last page of this lab is a tangent, a trig table. And I figure out what the tangent of 67 degrees is. Make sure your calculator's in degrees. And for me, the tangent of 67 degrees was 2.356. So then this distance from my corner here, my 90-degree angle, to here should be this length times the tangent of this angle. And so I calculate that out, and for me, I got 179 centimeters. Now then, I want you to actually measure the length of the table. And if you measure the length of the table, in my case, it was 197 centimeters. So I had some error in my measurement. I could have made an error in my measurement here, which is unlikely. Most likely, my error in measurement was in the angle. In fact, the actual angle, if I were to calculate it out, would be 69 degrees. So that's really hard to see the difference between a couple degrees on your protractor. That's okay. The thing to get is that your angle is the most important, the most difficult part of your measurement. So now that we've done that, I want you to go outside and find a distant object. And this is what you're going to do. You're going to choose some point on the ground. And you're going to mark that with, stick a pencil into the ground, or mark it with a piece of chalk if you're on the sidewalk or whatever. And I want you to, get down and look for some distant object and kind of draw that line in. You can use a piece of string if you're out on the grass, or draw with a piece of chalk on sidewalk. And then I want you to take a 5-meter long piece of string and lay it out at 90 degrees. So you're going to have a protractor that you'll measure here exactly 90 degrees between this site that you're looking down at the distant object, whatever it is, a tree, a flagpole, or building, I don't care what it is, and your baseline here. Then I want you might need a second person to help you get this string very tight and straight. Then wherever the end is here, you're going to sight again towards that same object, and there's going to be an angle here, and you'll need to very carefully lay a protractor down and measure what that angle is. It could be a very high angle. Do your best to figure out what that is. So after you've done that, record your baseline, which should be 5 meters, record your angle, find the tangent of the angle, and you can find the calculated distance to your object. And then I want you, if you have a tape measure, you might need to use it several times to maybe find the actual distance of the object and see how close you were. The last part of this lab is doing the same thing, only we're going to simulate the distance to the moon. So I want you to look up again what the radius of the Earth is. That's going to be your baseline in this case. We can figure out the distance to the moon by looking at it at 3 months later. So maybe when it's directly overhead, and then maybe someone else over here on the edge of the Earth, look at what angle it's at. If you do that for the Earth, the angle is about 89.09 degrees. You can calculate the tangent of that. That's either your calculator or the table has that value. And figure out the calculated distance to the moon, and then what is the actual distance to the moon. I have a question I want you to think through. Write a paragraph or two kind of explaining your answer. Scan the second and third pages of this lab as a PDF and submit it on Angel.